So let's say we have these two triangles, triangle ABC and triangle DEF, and maybe I tell you that side AB is congruent to side DE, and that side BC is congruent to side EF, and that angle B is congruent to angle E. Well, we would know that that's enough information for us to say that those two triangles are congruent to each other. We only know three things. Three pairs of corresponding things are congruent. Two pairs of sides and one pair of angles, but that's enough for us to say that triangle ABC is congruent to triangle DEF by side, angle, side. Okay, so now that we know that these two triangles are congruent, we've taken that shortcut. We didn't have to prove all 6 things were congruent. We didn't have to prove that all 3 pairs of sides were congruent. We didn't have to prove that all 3 pairs of angles were congruent. We only had to prove some combination of 3 things. Well, now that we know that those triangles are congruent, well, if triangle ABC is congruent to triangle DEF, wouldn't that mean that angle A would need to be congruent to angle D? Now that I know that those triangles are congruent, that makes sense that I would be able to say that angle A is congruent to angle D. Or maybe instead of talking about those angles, maybe I wanted to say that side AC was congruent to side DF. That makes sense. AC corresponds with DF. So I could say that AC is congruent to DF. So what we're doing here is, because we know that those two triangles are congruent, because we've proven that the whole entire shape, the whole entire triangle is congruent to this whole entire triangle, that means that all 3 pairs of corresponding angles and all 3 pairs of corresponding sides are also going to be congruent. So we only proved 3 of them. Now we can prove all of the remaining parts are also going to be congruent. So we use, the justification is called Cpctc, and it's an acronym. It stands for corresponding parts of congruent triangles are congruent. And the way that we use it is, once that we have proven that 2 triangles are congruent by one of our shortcuts, then we can prove that any of the other remaining pairs of angles or pairs of sides are congruent as well by Cpctc. Because angle A and angle D are corresponding parts of congruent triangles. We know the triangles are congruent, so we can say that they are congruent. Or side AC is congruent to side DF, because AC and DF are corresponding parts of congruent triangles, so therefore they are congruent. So you can only use Cpctc after you have proven 2 triangles are congruent. So you would never use Cpctc before you'd use side, 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 angle, 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 side, or hypotenuse lead. You would only use Cpctc after you've proven the triangles are congruent. So first you got to prove the triangles are congruent, and then you can say a pair of corresponding angles or a pair of corresponding sides are going to be congruent by Cpctc. You would never, ever, ever see Cpctc before you saw one of our 5 shortcuts in your proof.